So, running FaaS with scissors. So we've kind of heard all this. I've got a long background. I can actually get all of my weight high enough off the ground to break 2 boards at once. I did that in April. I still have knees, which amazes me. This was my 2nd degree black belt in Tong Sudo Migu Kwan in April that I tested and passed. That was quite rigorous and interesting. Hallelujah, I got it done. And you already heard my background. I'm not going to repeat all that stuff. The other project that I'm highly involved in, and you'll see a little bit of it today, is Defect Dojo. So, not everything about completing a goal is sunshine and roses. Like, this is the sexy shot, right? This is what's going to be on Twitter. Like, look at the cool thing I did. But you know, behind that cool thing was a boatload of these kind of days. And if you can't realize it, I'm bloody tired there. So, I'm going to show you some cool stuff, and I'm not going to lie to you, there's some work behind it, right? So, I think these things will help you, but I don't want to sell you the magic box. This is what you'll see in the vendor pitches. But honestly, there's always going to be some of this. So, what is serverless, right? Well, at the end of the day, it's someone else's computer, right? If you're a longtime Linux person, you might remember Zinetd or XInetd. If you don't know that old-time Linux service, it was a service that let you take a binary that wasn't used to answering to network and let it answer to network. Zinetd would go and handle the networky stuff for you and then pass it down to your application. Your application would run and do its thing, and it would handle all the closing and opening of all the TCP stuff for you. That's kind of what serverless is. You write some code, and your function as a service or Lambda or whatever you want to call it provider handles the rest. The whole idea is to move boilerplate of this handling connection stuff, which is kind of the same every single time, to the provider. Give me the HTTP and what I got in, and then it's my problem, right? And ideally, you're focusing on business value rather than doing a whole bunch of boilerplate code that doesn't buy you anything. And in my case, I want to focus on solving security problems with serverless. So if you think of serverless, it's really functions where you do the work. There's events that trigger these functions. These could be a time-based event, or this could be a trigger because some change happened external to the system. And then you have some sort of managed services that make those two things work for you, right? That could be Lambda, that could be Google Functions, that could be whatever. So a pretty picture diagram to get an idea of the difference, right? As a developer, you have the black items, and as the vendor, they have the green items. So if you're doing traditional infrastructure as a service, most of it is your problem, right? And a little bit the infrastructure is handled by the vendor. When you move to PaaS, now you've handed off operating system and runtime to the vendor, and you just have the application and functions. And then obviously for functions as a service or serverless, all of the stack goes to the vendor, and you're just really writing some bits of code that get called automatically via the whatever, usually API calls coming in. Common uses, they're usually fronted with REST APIs, microservices, those kind of things, where you have one function per method and some kind of API gateway that sits in front of it that brokers those connections in and out. You can also do data pipelines where you have some kind of event. You have one or more function munge that data in some sort of way and then push it off to a final receiver. Gotchas. Most of these services have trigger URLs, which are really handy. You have to, when you're trying to like debug and run these things, you kind of have to put them up on the service and run them, because it's sort of hard in most cases to do debugging and testing and stuff locally, because you're using AWS Lambda or something else. Observability is super important, because if you remember back here, this is black box to you. So almost the entire stack is outside of your visibility. So observability in your code, the little bit of function code you write, is really important. You can get bit if you have a traditional mindset about development with DB connections, because these things come up and get killed rapidly. And in your mind, if you have a connection pool of 3 or 4 connections, well, your service is getting up and down killed, and then 3 connections, 3 connections, 3 connections, 3 connections, all of a sudden the database pool is full. So you really need to wire those down to 1 and set low timeouts. And these are cattle, not pets, right? These things should just be run and thrown away. You shouldn't have some warm, lovely feeling about these functions. They just run and do their work, and then you kill them. So, should you be scared of serverless? Well, what's the traditional answer to new tech from security people? What's that answer? Yes. Should you be scared? I say no. You shouldn't be scared, right? Now, yes, the traditional answer is no. The traditional answer feels like this. This was a flight I was landing in Detroit, and we got followed by fire trucks as we were, but we had to actually land and then come back. It was rather interesting. A bit of smell of smoke in the plane. It was a little bit of high drama. But this is kind of how it feels when you find out that all of a sudden that dev group is going to do this new weird tech thing, and you've got no clue about it. I survived that event. You'll survive this event. It's okay. And you can make mistakes and be stupid in any programming language or with any technology. Like, it doesn't matter. Like, there's nothing inherently wrong about serverless that makes it riskier or unriskier. It's how you use it. You give a craftsman a hammer, he can build you an awesome house. He can also smash the hell out of his thumb, right? Infrastructure is run by the provider. Hopefully they're doing it at least as good, if not better than you. You're writing a lot less code, so if nothing else, the bug count should be less. And the easy path, like if you're trying to do automation, this is an easy path to get you from these like one-off little scripts that you ran into something much more industrial strength, right? If you are writing these little one-off code things, those things could live in a serverless function and actually be managed and maintained by whatever provider you have or whatever infrastructure is in place. So, the big picture, thinking in serverless. I love exploded diagrams. I don't know why, man. I've just been fascinated with them forever. To me, they really speak to me. And I love the fact that you can sort of see all the pieces and how they fit together and how they are individually. And if you think about serverless, that's really what you want to do. You want to take down, take apart, rather, those processes that you do as a security person and break them up into the pieces that constitute the workflow you want. Right? So some kind of something happens. I have a deploy to UAT. Some code gets committed to a repo. That's an event, right? You take some action based on that event. Maybe I'm going to run SAST against that recent code commit. Maybe I'm going to go do a base security baseline to check that new deploy to UAT. That's a function, right? And then you inform the product team, right? Maybe you drop a message into Slack that says, hey, this commit 1, 2, 3, 4, 5 in Git on this app has this problem on this line because I ran the SaaS tools. Hey, we looked at you in UAT, you forgot to turn on those headers. Whatever you want, right? But this is sort of the big idea, or what my idea of using serverless, right? All these little checks that you might do manually, automate them, make them callable over HTTP, and then this can just get done very easily. You can kind of make an easy button out of these checks you want to do. So how do we use these powers for good? And I just have to put this in here because I love this cartoon. Like, sweet Jesus, Boo, that's not honey. You're eating InfoSec propaganda. Machine learning, cyber blockchain, hacker, CISP, right? So, as an example of how to explode your process, think about the OWASP testing guide, right? That has, I can't remember how many, 60 some odd different tests in it, right? How could you turn those things into functions? Because really, if you think about when you're doing like a web app assessment, you're going to do so many sort of checks as you go. How many of those things can you turn into something that's just an automatically running function? Well, search engine discovery and recon, info 1 of the testing guide. Write functions to do your favorite Google dorks. That's not a really hard thing to do, to automate. We're talking small lines of code, but that gets you some really interesting value. And now that it's a function, you can call it all the time, right? Call it regularly and look at diffs. Fingerprinting a web server, right? Pull the X powered by headers. Do whatever you need to understand what that server is running. Review server metadatas. Write a function to pull robots.txt, crossdomain.xml, sitemap.xml. Check those files for problems, right? You can even do diffs. Like if you know that the last 2 times you pulled crossdomain.xml, it had these values in it. If you get a new value, you can react to that diff. Right? These are ways that you can automate sort of catching changes. You can check headers, you can check method. TLS is an easy thing to automate as a function, right? If you have custom checks for your apps, maybe you're a .NET shop, and and you have certain settings you have to have in your web config according to policy, that's a really simple grep of a web config. Why isn't that a function, right? Every time you commit code, that function calls, and you know you're not regressing, at least in the baseline security calls of your .NET app in that case. What else could you do this with? It goes beyond AppSec, right? If you're doing DFIR, reverse IP lookup, IP reputation, blacklist, domain reputation, these are all things you do when you have some funny IP traffic on your network. Right? If you're in an incident response role, you're gonna do all of these kind of checks. And these are fairly simple, easy checks, but they have to be done every time you have a hinky IP show up. Why aren't these functions? Why can't I call the one function that calls all these functions, sums up all the data, and ships it to my analyst? And now in a minute or two, he has a slate of information about that funny IP that showed up on his console, rather than going out and running an NSLOOKUP and running a tool and running a tool and running a tool, right? Big, big time-saving bonus. So building blocks, right? What are the building blocks of serverless? Well, there's AWS Lambda, Azure, IBM, Oracle, and Google all have functions or cloud functions. It's all basically the same thing. There's an awesome project called OpenFaaS. You can run on-prem, or you can actually buy it from that project as well. There's a ton of different frameworks. There's serverless, there's Sparta, there's Furnace, there's whatever programming language you have, there's a framework for you. So you shouldn't be limited by the fact that, like, I do Java, but there isn't a Java thing, or I do Python and there isn't a Python thing. There is. Like, people, it's not hard to get into this if you have the desire to write a little bit of code. And if you haven't seen this, the Cloud Native Alliance, or CNCF, what is that? The Cloud Native Computing Foundation, there we go, at s.cnf.io has this awesome interactive map of all these different cloud technologies. So that if you want to know about hosted options, here are your hosted options. If you want to know about installable options, here's your installable options. Here's a bunch of different frameworks. Here's a bunch of different tools. There's some security stuff you can do. That is a super handy resource. Highly recommend that. It's kind of all of the stuff is in one web page. And then all of these little squares, you can click on them and they expand, and it's dynamic. It's pretty sweet. Picture taking done, good. Nope. Oops, I'm gonna vamp for a minute. Perfect. So I want to have a special shout out to OpenFaaS. I particularly like that project. It's an open source project. It consists of an API gateway and a watchdog. It has built-in Prometheus. You can run it in Kubernetes or Swarm. And the nice thing is these functions are basically just Docker containers. You make a container that does a thing for you, and they turn it into a callable resource over HTTP, which is really pretty cool, because it's not that hard to Dockerize something. And once you have that, now you have a resource that's callable over HTTP, or HTTPS, really. The idea with OpenFaaS, you make a REST call in to the gateway. It will store some stuff in Prometheus that has an alert manager. Really, it's going to call the provider that can either be Kubernetes or Docker Swarm. Swarm is nice for laptop. I would do Kubernetes if I was doing it for real. That can go out and call whatever functions, right? That'll open up Docker images that you specify. All this stuff is sort of managed secrets and deployments and services managed by Kubernetes. It's just a really interesting system, and it's a $0 cost system if you want to run something on-prem, which is nice. Or it works great on a laptop. So demo time. I have 3 demos because I don't like myself. We're going to try this out. Okay. Oh, I should say, so that worked. Maybe this will work. Because I actually stuck my dishwasher in my trash can, and they actually picked it up. I was really shocked. My kid took a picture of it. I was like, it fits, like they should take it, right? And they did. Good trash company. So this is the first one I'm going to talk about. Gasp Docker. It's an open source project I have up on GitHub. The idea with Gasp Docker is it's a way to sort of specify one or more tools that you can run against a target being either a dynamic application that's running or source code in some repo somewhere in a Git repo. So you make a specification that says, hey, when this event happens, I want you to fire off these 3 Dockers to run these 3 tests against it. Take all those results, ship them back and leave them in Defect Dojo, Defect Dojo is a vulnerability management platform. It takes in dynamic, static, infrastructure, container. It reads in 69 different tools right now, and it import them and normalize them into a nice data model. And so what can you do with this kind of a thing? And that's demo 1. Is this readable mostly to people, hopefully? So we're going to run the Gasp demo, because this is a demo. In this one, as a startup function, and by the way, there's 3 ideas of the Gasp pipeline, or AppSec pipelines in general. You have a startup function that does some sort of pre-work to set up an environment for testing. Pipeline actually does the testing, and then final is either doing cleanup, pushing results to somewhere, or something like that. So in this demo, we're going to run Git and clone a repo. We're going to run Bandit, which is a Python static analysis tool, against it with the all profile. And then I'm going to run the Defect Dojo Docker, which is really just a shim that takes the results that happened above it and shoves them all into Defect Dojo. There's a second YAML file called the sec pipeline config, and you basically define for the Bandit tool, here's some metadata. Importantly, there's the Docker that's going to run, and then commands that you can send to it, and then profiles, which are different ways to run that Docker. These are basically command line arguments that get sent into that Docker to specify how it runs. And so you have like a consistent way to rerun a Docker by giving it a profile. And I have the same thing for Defect Dojo and Git as well, just so you get an idea. Oh, and then let me, oops. There we go. I have Defect Dojo up and running. Right, this is Defect Dojo. It manages your vulnerabilities, like I was saying earlier. If I can drive over my shoulder. So I have a bunch of just Nintendo products in my real life Defect Dojo. And if you look in here, you can drill into these things. Like for instance, Donkey Kong has had an engagement. So here's 3 different engagements where we've interacted with that product. If we go back, we're going to actually do this to Mario Bombs Away. Right? And so you can notice there's no vulnerabilities, there's no findings. If we view engagements, there are no engagements. Let us go back to our terminal. Yes. And I am going to, what did I do? Yes. Just so you can see it, because the command line is not short for Gasp, I'm going to run Gasp Docker, running the profile, that's -p of Gasp demo. This is for the last con demo. The Git URL, I'm pulling an old copy of Defect Dojo. I'm dropping that source code checkout into AppSec pipeline source. And then those Dojo commands are different ways. This is what the Dojo Docker needs to talk into the API, the key, the location, what product it is, and where to find reports. So if we run this thing, and I vamp for a few seconds. Last time conference Wi-Fi. So right now it's going and pulling from GitHub a copy of the Defect Dojo source, an older copy of the Defect Dojo source I have in my repo. Come on, slow network. Usually is 30. I ran this last night in the hotel and I got 41 seconds. We'll see what it goes. Oh good, we're in the second stage. Now we're in the pipeline stage. It's actually taking the Bandit Docker and running against the source code it checked out in this step. Once that step is done, there we go. It's running the Defect Dojo Docker now, taking the results from Bandit and shipping them into the Defect Dojo API. And hopefully in a few more seconds, it'll come back. 45 seconds, that's not too bad. So we checked out of Git, we ran a static analysis tool against it, and now have those results in Defect Dojo in 45 seconds over a crappy conference Wi-Fi on a laptop that's, actually it's a pretty nice laptop. I shouldn't dog my laptop, I just got it. If we refresh here, you will see we have findings. If we view engagements, we have the profile that I used automatically opens and closes the engagement. When it submits them, there's a whole bunch of other options you can do, but this is our engagement. If we drill into that guy, we can see that we had a Bandit scan ran. And if we drill into that guy, we can see all the findings, and then we can drill into one of the findings and see what's wrong with Defect Dojo, at least this old copy of Defect Dojo. So that's this idea. Like, you can do this kind of thing by just building up a bunch of simple functions and wiring them together. And if you want to play with the Gasp pipeline, it's up on GitHub. It's written in Go, so it runs on Mac, Windows, and Linux, and you just need Docker. It basically stubs out to Docker. Oh, yeah, and this is where Gasp Docker is. I also have all the Docker files for the Docker tools that are in there as well up on GitHub, also under the AppSec pipeline repo. Oh, oops. Oh, yeah, OpenFaaS. So OpenFaaS is the next thing I'm going to show you. It's up on GitHub. I forget how it's licensed. It's open source license. It's BSD or something like that. Let me go to the right place. So what are the nice things about OpenFaaS? Where's my pointer? Here's the website, but even better, here it is running locally on my laptop. That was testing some stuff earlier. So these are just different functions which basically map to containers that are sitting in this install that's running on my laptop that I can call in any way. They automatically give you a UI and a Prometheus to monitor the usage of it, which is pretty nice. And you can do things like, let's see if this one works for me. This was being really slow earlier today. So if Bill at Microsoft.com wants to know if he got pwned, because I got to type Microsoft correctly. Actually, I saved myself this trouble. Oh, I didn't. Shame on me. Okay. Bill at. We want to see if Bill at Microsoft.com has been pwned. We can invoke it through this UI. And apparently 3 different instances were found in the Have I Been Pwned database, just as a silly little example of the things you can do. So there is this nice UI if you like UIs. There is also, so do I have that there? Yeah. You can do things like run Nmap from this guy. I'm just going to Nmap myself so it's quick. It'll fire up that container and give you results back. The nice thing is that that's basically taking those Dockers and turning them into callable resources over HTTP, which is pretty sweet. There's also a FaaS tool, and OpenFaaS, F-A-A-S. There we go. OpenFaaS has a built-in store. Did I type that correctly? Yes. So these are ones that are just default that come with OpenFaaS. You can do things like if Figlet is a command line tool that takes text and makes it into ASCII art-ish stuff. So if I want to deploy that to my current OpenFaaS, it's literally just FaaS store deploy, and that's it. Oh, yes, I got it. Okay, 202 accepted. Yes, yay. Right, done. Another nice thing, if you are programming against OpenFaaS, is they have a ton of pre-built templates for a bunch of different languages. So these are all languages which they have stub frameworks for you to make Dockers out of. So if you're a Python programmer, you want to write Node, or you want to write Go, or C# or whatever, they give you these stubs, and you can do FaaS, I can't remember the exact command, but there's a command line that'll actually give you a stub of code that you just run, stick into a Docker. There's a YAML configuration. You push that into your OpenFaaS, and you're done. It's pretty stinking simple. So as an example, I have a YAML I created for a mass, the OWASP mass. It's a DNS enumeration tool. That's actually pretty cool. So here's a very simple little YAML file configuration that's going to grab mtesaro amass 3027. That's my Docker that I created with the amass tool. If I want to actually deploy that to my local, there we go. You just do FaaS up and then point at that YAML. It's already now up and running. If I flop over to Firefox, You will see I now have a mass installed. It's just that easy. If you do a new Docker, it's just a matter of updating the image reference on that YAML and doing FaaS up again, and boom, you have a new Docker. It's pretty amazing. And the interesting thing is that for things that are normally sort of command liney, I can now do interesting HTTP things. Let me clear this so I get up to the top of the screen. There we go. So I'm just calling curl to my OpenFaaS endpoint and running Nmap on my local host, and boom. So you can take tools that you would normally have to run, on your laptop or in a server somewhere and turn them into web calls, which is really pretty powerful. The next lab I was going to show you, or not lab, next demo I was going to show you is Alfred, which is not the Mac OS X Alfred or the 432 other things on GitHub that are named Alfred. I found this out by telling a friend about this, and then it's like, I'm looking on GitHub and I can't find it. And I'm like, oh, it's just this. But there's like 87 different Alfreds, unfortunately. It's a really nice, very simple YAML-based task runner. So you can define these simple tasks in YAML, and then it will go and run them. And you can stack them, you can have groupings, you can have whatever you want. So it's a very nice way to sort of take what would be command lines and just make them simple little calls. So if we jump over here, Alfred command, when you just run Alfred by itself, it'll tell you all of the pre-configured tasks it has. So I have a cert expired, cert raw, hoster, which does host names. You can define all these things that come out when you run Alfred. So it's just a nice kind of convenient little way to sort of wrap up these things in an easy to call method. So if I do Alfred scan localhost, it's going to call out to Alfred. It's going to run that Nmap container that's up on OpenFaaS against localhost, just like I did before. Now it's just a simple call. You can also accept arguments, which is really nice. Right, so I just ran scan localhost, this top one that's hard-coded to only scan 127.0.0.1, obviously a trite example. But you can do an Nmap scan and just do index args 0 and pull in command line args. So now you can pass command line args into your commands and just have it all sort of work. So you can make these more dynamic commands. You can also do groupings. Like this one will call these two different already set up tasks. So you can sort of do groupings in multiple tasks. So you can sort of build up an arsenal of little tasks and stack them together in any sort of way you want. And there's a bazillion other features, obviously. It's pretty surprisingly full-featured. So let's run an Nmap scan using Alfred and passing in a command line argument. Like this. So here's me running it. Now, this is kind of nice, but it's also kind of annoying because I have these logs, which are sort of nice when you're debugging, but if I just want the output, it's sort of not so awesome. So I don't want that output. And I did a little bit of cheating, because that's what you do when you need to make stuff work the way you want it to. At the tail end of my bash RC, I'm aliasing automate to Alfred-no formatting, which gets rid of that logging stuff, which is nice when you're trying to figure out how these things work, but is kind of annoying when you just want to see the results. So let's automate that Nmap scan. Here we go. There, right? So this just looks like an Nmap scan, right? And any kind of arguments you tack on the end of there, -t4 or whatever, that will just happen. Now you can also, if you want to, hard code those in a Docker. If you want to sort of have a standard way that you scan, say, internal resources with Nmap or any other tool for that matter, you can hard code those into the Docker. And now every time it runs, you're getting a consistent run. The other interesting thing about turning these tools into HTTP calls is now wherever my OpenFaaS lives, that's the originating IP of my call, not my laptop. So if this OpenFaaS was deep buried into a VPN-ified VPC somewhere, I could still run commands inside of there from my laptop, just brokered through a VPN connection to the HTTP front end of OpenFaaS, and then my source is inside of that secure area. So it's a sort of a nice way to bring tooling into environments that are otherwise constrained, which has been, I've had other times in my past where trying to test environments and then asking them to poke holes in firewalls is not so awesome. Maybe a single hole for a 443 isn't so bad. And then, last but not least, showing the grouping and automating you can do. So this one is going to resolve the host for lastcon.org, and then it's going to take a while because it's going to do an Nmap scan of lastcon.org and come back with the results. Luckily originating from the conference IP and not my laptop IP. Cough, cough. But this will take a while. It took a while earlier. But the idea here is you can combine and mix these things now, right? You have several functions that you've created. You've put them into Dockers, and now you can just mix and match them. Now, Alfred is a fun little tool to play with on your laptop. If I was doing this for real, I probably wouldn't use Alfred in a production environment, but certainly for automation of tooling local to your computer, it's great. Things you can do, oh, there we go, we're back. Done. Right, so now we just nmapped lastcon.org and resolved this IP, right, by combining those two Dockers. Back here, there we go, that's Alfred. Wow, all my demos worked. That's like spooky, that's 3 demos on film. And they all worked. I'm almost like afraid. So what do we get with the serverless security automation? It's not in-depth testing. This is not going to replace your pen testers. This is not going to replace your security professionals. But it is going to make your security professionals move a lot faster. Because some of that dumb, rote, repetitive work, you can containerize, standardize, and just make them calls. And yes, this isn't like Leet Hackzor has spent a week poking at your thing. But this is a you must be this high to ride the ride. And the other nice thing is once you've turned these into containers and easily repeatable functions, you can do things like run that same tool across all of the repos. You have 84 repos. If you had to do that manually, you're talking days and days of like git clone, I want to kill myself. No, just point this tool at it, feed it a series of git URLs, and off to the races. Right? So now you can do this baseline. You can actually get an idea across the suite of your applications what the security state looks like from a static or a dynamic perspective. Just depends on what tool you run, right? So this is where it gets really cool and powerful. Because now I can get breadth, which was always kind of a problem. It's not super deep breadth, but I can get breadth. And then I can have my people work on getting depth in the applications that need it, because maybe this one that feels low risk is a basket case, and by the way, it's publicly exposed. So I might want to actually put some resources on that I wouldn't do until I knew what was a basket case, right? But if I'm just looking at raw sort of risky things, that one doesn't do much, it's not that important to the business, we don't drive revenue from that thing, I'm not going to look at it, right? And it falls off the back. So, welcome to the world of serverless automation. It's all rainbows and unicorns, I swear. Not really. But Batman does ride a unicorn from time to time with his dolphin friends. And that's kind of it. This is way faster than I thought it was going to be. I'm happy to answer questions. I also have some other slides, by the way, of different versions of this kind of idea. This is the high-level AppSec pipeline. This is more as a global program. I would say the serverless tooling kind of fits in here, where you're automating tooling, as opposed to the full sort of workflow of an AppSec program. And this stuff's up on GitHub in the AppSec pipeline project as well. Certainly this ping is. But the idea here is that you start over here with, well, I have a laser pointer. You start over here with requests that come in. I do some kind of triaging. I hopefully run a whole bunch of tools in an automated fashion. I dump everything into a vulnerability repository like Defect Dojo. I can push things to defect trackers, do metrics, and sort of feed all those downstream constituencies. Here's an example of the first one I did at Pearson, where we went, I think I have numbers, but this one mistake we made, and I'll tell you this so you don't make this mistake, we had an application to handle triage and intake, and we had an application to handle all the vulnerability stuff. That was painful because apps in here and their IDs had to be synced with apps in here, and having two really didn't buy us much. So in future versions, I just smashed everything into Defect Dojo. But using this setup, I don't have numbers. I thought I had numbers in this one, oops. I don't have numbers, but in this setup, Pearson went from 44 assessments in year 1. 2 years later, we got to 400 assessments, and we lost 3 people on the team. So we lost people and went faster. And a lot of it was just a ton of little glue code to cut off rough edges that busted knuckles of the security team. So you can get crazy ROI on this stuff. This is one that we talked about doing at Austin, never got done for OWASP, but it's just another idea of, I pull code out of a project, run it to some kind of automator like Jenkins, launching Dockers that push stuff to findings into Defect Dojo. You can shove validated findings from Dojo into Jira, and optionally drop things in Slack channels for project teams. And here's another instance of the pipeline that Aaron Weaver, my co-lead on the AppSec pipeline, did. He was a very Atlassian shop. Developer checks in code. That code with the webhook tells the pipeline, hey, we had some code checked in, launches a bunch of Dockers to look at that, takes those results, saves them in Defect Dojo, gives a summary to the Slack channel, hey, we just ran all these tools and here's what we found to the developer team, and then puts findings into Jira so they can have something to work on, like, right, drop it into their backlog. For that pipeline, he actually was smart and took numbers. He had 15 repos over 4 months. He ran it 5,100 times for over 25,000 container executions. This is what I mean by making an easy button. Like doing these things becomes like, donk, it happens, donk, it happens. It makes it really easy, and you can run these things all the time. You can do really interesting things. At another instance that I did this, we did a GitHub commit hook on their enterprise GitHub that would run a bunch of static tools whenever they dropped code into the repo and did a commit, take those results and drop a message into the Slack channel of the dev team. So now you have a few minutes from I committed code to I get @referenced in Slack that said, by the way, Jimmy, you submitted some code, and on line 47, here's an issue, we should talk about it. Right? It's not like the quarterly assessment, it's the 5-10 minutes ago assessment, which is really nice. And this is another version of it. Oh, there's the numbers. I knew I had numbers. There's the numbers if you want to see real numbers. That was the delta we had. We lost 3.5 and then 2 people, so we went down over time, but increased our speed. And that was mostly really just getting rid of paper cuts. I think that's all. Yeah, and over 2 years, it was almost a 10x.
Does OpenFaaS come with security, like a way of securing the APIs, or is that an assumption it's all local?
Yeah, my install right now is crap because it's on my laptop. Okay. But at least, like, I've been playing with it for about a year, and in that year, they went from having a wide open HTTP by default to they force you to have a credentialed login. And then if you set it up with HTTPS, you have a credentialed login over HTTPS. So yes, you can do a lot of security stuff on it. My laptop right now, it's just a demo install. It's crappy, but yeah. Yes, there's a whole bunch of authentication authorization you can do in front of it. Yes.
Thanks.
Yep. Any other questions? Yes.
Hi, Matt. Can you comment on the status of the Defect Dojo?
Sure. Yeah, it's not really a Defect Dojo talk, but I'm a maintainer, so I know. This summer we had 2 students that were Google Summer of Code, and we also paid a college guy to do some work for us as well, so we had an intern sort of. We did a conversion from Python 2 to 3, so that we're no longer subject to the Python 2 dying in January, which is kind of nice. And the other focus of the Google Summer of Code was writing a whole ton of unit tests, so that I don't have it on the screen, but we have a sample files repo, so we have samples of the 69 different tools that Dojo can ingest in a repo, and the unit tests will pull those files out and run them through Dojo to make sure we don't have any breakage of tool import as a bunch of other tests internally to make sure that Dojo is consistent. Because one of the problems we faced as a project is the popularity of Dojo has really skyrocketed in the last year. And we're getting lots of PRs, which is really cool, but we're getting lots of PRs, which is also scary. So we really wanted to shore up the testing side of things so that those PRs were easier to accept without bringing in breakage. And then the other thing that I'm working on currently is I'm rewriting the installer because I hate myself, and I wrote 1,200 lines of bash to do the first version of the installer. I'm rewriting that in Go. And the nice part about that will be it's a standalone binary that knows how to pull it straight out of GitHub, drop it onto your box. And I also set up it's set up to either pull from a tagged release, a particular head of branch, or a specific commit. And then there's 170 some odd configurable things in a YAML file that you can either accept the defaults or override them with environmental variables or change the YAML. So it's like super configurable installer. And some of that's driven because our installer is not awesome, and I wrote it so I can say that, I guess. And some of it's driven because we're having to do testing for people like, hey, I have this issue. Well, to repeat it, oh, you're using like 12 commits back from master. I need to do an install of that, and so this will allow us to do those kind of testings a lot quicker as well. Yep, no problem. Any other questions? Well, thank you very much.